have a scene set up here. It's just a piece of test geometry and then 3 lights. The lights are positioned so that we get pretty even illumination of our objects here. And this will be useful when we look at a volumetric representation. So we're going to look at how we can actually color volumes here. So the first thing that we're going to want to do is to convert this into a density volume. So we'll just put down an ISO offset. Plug that right in, and this is already set to fog volume. I want to give it a name, so the name is going to be density. And then for the resolution, why don't we go ahead and say the resolution is 100. So I'm going to put down here a volume visualization. And this lets us bring in a bunch of different fields that we can use to control how this volume looks in our viewport. So you can see that I can scale density up. And then here we would actually say the name of our field. So that's density. If we had other fields in here or we wanted to see them visualized, we could just change the name that's coming in. And we can change shadow scale, and then we have a bunch of remapping options here as well. But for now, we're just going to keep shadow at 1 and density, we'll say at something like 10, so that it looks fairly solid. Now you'll notice that we have a tab here for diffuse field, and this is how we are going to show the color in our volume. We of course can use solid colors here if we wanted to. I would just, I think, change something like that. Make sure that's red. And then we could just say that density, is our diffuse field. And then we can color based on density. If I wanted to make that something like green, you can see that where we have 0 density, which would be the outside of our object, it's going to be green. And where we have full density, density value of 1, we're going to have red. So if we wanted to use density as our field for color, we could do that, but we'll want to use our own custom field here. I'm going to go back to no ramp here. So what we'll do is we'll make a custom color field. We will put down an empty volume. Just plug that right into test geo. I'm going to copy the sampling here and paste that right into the sampling here as a relative reference. And the name here, first of all, we want to change from scalar to vector because it's color. We need red, green, and blue, so we're going to need a vector. And the name is CD. For properties, I'm going to go in and change the border type. So that's what's going to happen as we get to the outside of the border or along the edges here. And I'm just going to choose streak. So if it finds a value, it's just going to streak that value across the box. So we have right here an empty volume. Nothing is in here. There's no data in here. We need to define something. So let's do something quite simple here. We will put down a volume VOP. Just wire that straight in. And we're just going to use the bounding box information to color. So it'll go red, green, and blue across the, I believe it's going to be the X, Y, and Z axis here. So we'll just go ahead and type bound and grab a relative to bounding box. File is going to be the first input. And then position goes into our position. And then all we need to do is bind export. Change that to 3 float vector. Wire that right in and give this the name CD. And now you can see that we have some data in here. So you notice volume visualization only has 1 input, and the way volumes work is that they all have to be merged together. So we're just going to merge that in, wire that in, and now when we look at this, if we take the diffuse field and we grab CD dot star, Now you can see that that bounding box information is showing up here as color. But what if we wanted to use a texture map or do something a little more interesting here? We'll go ahead and do that. We're just going to take the test geometry here, and I'm going to scatter a bunch of points on here. I'm going to make it quite high. And to give us something quick to look at, I'm going to use an attribute from map. So this allows us to use the texture coordinates and assign a color map just based on the texture coordinates. So it's going to grab the default one, which is the UV color here, but we could use any texture map we want. I'm going to keep it right here on UV rat, just so we can get some idea of how well this is actually working. So all we'd have to do here is find a way to convert this information into a color volume. And we have an easy way to do that. That is a volume from attribute. So all we do is plug our volume into the left, and then our attribute into the right, and enable this. Now it's going to ask us which attribute we want. We want to make sure we choose CD. And this should be good for now. So let's take a look at our volume visualization here. And we'll just bypass this volume VOP and go straight to volume from attribute. And now we can see that we have the UV texture coordinates right on here. So in terms of resolution, we have two things here that are controlling that, or three things. We've got the resolution of our density field, the resolution of our color field, and then we have our initial point sampling here. So all of these are controlling resolution together. And let's keep in mind here that we could go higher if we wanted. So I'm going to go to something like 160. Let's see what this does for us. There you go. You can see that we have much more resolution. We can start to see some of the numbers. And then if we needed to, we could go even higher here. So that's a pretty simple way of showing how to color volumes.